Boom, boom, boom. Yo. Yellow, yellow guys. Let us uh begin. Continue our journey into learning AI agent. So far, let us actually recap what we have done so far. Excalidraw, where is it? Excalidraw, there it is. We are right here. I don't wanna, yeah, नीचे चले जाते हैं. Best thing. So what I was doing so far was basically let's just review the code. Import OS, import OS, or import OS usually gives like authority on your files, and .tn from .env import load underscore .en. And so this is basically used to load variables from the file .env. .env is a file where you don't matlab it is actually in git ignore, so you don't really push whatever that is inside .env. Hence, you don't really push out your passwords of what is it, like your database or something that is really important. In this context, it's my API key. Hopefully, no one's gonna. I don't think no one's seeing this, but if someone does, it is really dangerous. Cause I can't just put out my API key out there, cause they're gonna they're gonna sell my whole क्या बोलते हैं खानदान का पैसा. So I don't think the good thing. So what I have done, what this guy has made me do is um he made me write a function, main function, and the first thing that does is load.env. So the first thing it does is it actually gets the Gemini API key from the .env, which is like os.environ.get API key. That's it. From Google import Gemini AI. Yeah, from Google import. I don't really have to do it these many times, right? I can just do it once. Let me put it right here. From Google import Gen AI. Sorry, from Google import Gen AI. Also import this. This does is helps us, interact with the command line. And Gen AI is the most basic, is the most basic. What do you say? This is the basic module that helps us use the Gemini model, right? So client is Gemini dot client, API key is API key. This actually activates the API key, lets them know that we have the API key. So help me become a client, right? Now that I'm a client, client has a certain privilege. We'll look into that. And this line of code is something that is a little important and distinguished. What this says is systems dot sys dot argv. So what is sys dot argv? So these are the mm, system dot argvs, right? So it is actually stored in a list, right? All the arguments that you give in the command line, they get stored in a list. So the first one would always be the file name, because we have to run the file. So that's that. And the second thing, we are kind of hard coding it. It's not really nice, but that's how he's like trying to teach us. So I'll go with it. So this is the first one, and the second one is give me a 5 word answer. So this is our prompt, right? A prompt would be the second what do you say? The second object in the list, right? Second item in the list. So we have a list of first the file name and the second is the prompt. So what this says is the length of sys.argv is not 2. That means that if there is if there is okay, but this is actually a little troublesome. Let me say length is smaller than 2. If it's smaller than 2, what happens is you have to say print give me a prompt, right? Cause what happens is you are just getting the file's name in the command line, which matlab, you're not getting the prompt itself. So what the if condition says ki give me the prompt and system dot exit 1. So what this does, I guess, is like it exits from the command line. Let's see what this actually means in more depth. What is this dot exit? Exit Python, right? Is a way to stop a Python program and return and exit code to the operating system. Import says if API is key none is a way to stop Python program and return and exit code to the operating system. All right. What does one mean? One is general error or failure. All right. I mean in reverse. All right. Other numbers, different error codes depend on program. Why use it? Suppose your program needs an API key. Without sys.exit, the code would continue and eventually crash somewhere. All right. Uh-huh, uh-huh, uh-huh. Uh-huh. So this means this actually tells ki you have to exit. I mean, I don't want to go in depth ki kya, what is like, why should we tell to the OS ki we need an exit. But let's just assume that this is what happens, right? System.exit is 1 and prompt is system.argv 1. So because definitely the second thing would be the prompt, right? Second thing would be the prompt. So that's that. And messages. So this is something also that was quite strange that yesterday that when I've seen. So messages is a list. Matlab, the type this is type hinting, I guess. Um, it's a list of types dot content. Content contains multi-part content of a message. Content as a class contains the multi-part content of the message. All right, this actually contains the multi-part of the message. And uh, types dot content types, it's a module. I mean list is list, so which is the list of types dot content. Types dot content, let's just understand what's types dot content. Google Gemini SDK types of content represents one message in a conversation. Think of it like as this: you have a conversation, you have different contents: content, user message, content, model response, content, user message, content, model response. When you saw messages are in type list of types dot content, types dot content, mm, so role is user and parts are this. You're creating a conversation that contains one user message. All right. The structure of the content. A content object has two important fields. All right. A content object has two important fields. Types dot content, role and parts. Who sent the message? All right. And parts, the actual contents of the message. All right. So we have parts, which is actually a list. Types dot part, so text is prompt, so we're gonna initiate prompt in this, so that all right, that makes sense. So the user says ki hello Gemini, why parts is list, a message can contain multiple pieces of content. Oh, that makes sense. Oh, that makes sense, actually makes sense, because you can have a, describe this image and you also have to have the image, so you can have multiple parts of an image, this thing. That's dot part. Conversation example, messages. Okay, you have different types of messages. Types dot content. um what is type? So this is not types is not an attribute. It's a module that comes with Gemini. All right, you have to import types. It's a module. So then types dot content means get the content class from the types module. Oh, types is a module, guys. Types is a module. Now it makes sense. I have to write this down, I guess. So let's write this down. Here, CLI agent, guys. There are so many people that can benefit from this, bro. I mean, this is an ASMR class. This is, I go into agents, I go into backend. I mean, with the help of someone, but it's all right. It's all right. CLI agent, type, uh, then type method. This is a method or a class. It's a class, right? I guess. It is a class to get this content class. All right. So we are essentially making object of content. Okay, okay. And messages is a list of contents. Okay, okay. Now I get it. Now it actually makes sense. I don't know why he didn't really, go into the stuff with, but it's all right. I'm actually pretty dumb. I have to understand every other thing, right? So where was I? I was writing type of content is a. It's not a method, but it's a class. From that particular module, like the conversation. Does content act like a message in a like a particular message conversation? Right? Makes sense. Um, I guess so. Huh. Hmm. Like a particular message in the conversation. So it actually is like this, right? Let me just copy paste this. Got two parts. Got two. क्या बोलते हैं उसको? Types of content has role part. Parts. Parts is a the Types dot part who created types dot. This part is also a function of thought. Yeah, I guess it's a function. As a part is a class that represents one piece of a content that is inside an image. A piece of a content. All right, bro. This is. I mean, it's all right. Now I get it. The parts is parts objects. Parts is a list of parts object. All right, it makes sense. So, content has parts, list of parts, which is like bunch of parts of the part object. All right, that makes sense. Let's go to our code again. To print this anymore, response client dot model generate underscore. So this now what this does is client dot models dot generate content. What this does is simply generates the content, right? All right, yeah. But one of the things I just root this, right? But this actually doesn't really keep the messages, does it? Because every time I run the rerun the code again, not it's just gonna allocate the memory, and every time I rerun the code, it's gonna reallocate the memory again. I mean, it's gonna be a clean slate. I don't know where this guy's going with that, but it's all right. Let's see. So clients.models.generate content generates the content. So it takes in model and contents. Contents its prompt that we are gonna give from CLI, and also print response.text. Text. Yeah, this is our response text, right? Response.text is the text that we want to have, and response dot uses metadata is none. The response is malfunctioned. If else, if else, you print the prompt tokens, which is response dot usage metadata dot prompt underscore token count. So if you want to print the token counts of response and the prompt, you can use usage underscore metadata. Right? I guess that this makes sense until now. And one other thing that this guy said, let's rerun the code again. I didn't have to do that, but it's all right. Uh, Let me just yes. So what is the chicken cross the road? Who's saying hips don't lie? So what this guy is saying is whenever I say negative verbose, whenever I say negative verbose, something like this, then the CLI should be like, okay, if this guy needs the whole response, in the response which has prompt tokens, and also response tokens too. Because every time when we, every time when we hit the request, you don't really need the prompt tokens too. We just need that's something that developer is trying to manage. That is related to the developer, not a user, right? So let's just do that thing. He, all right, it makes sense. That is prompt. And if the text system.art, we just have to print that, and that's it. You don't have to print any other thing. Written is, if it's verbose, if the user wants the verbose answer, then this will do is it will actually check key response dot usage metadata is not none. If it's none, it's gonna say ki bhai this is malfunction. If it's not none, it's gonna print out the prompt and the response tokens. Let's just check this. Negative negative verbose, negative net verbose. Right. Let's see. Oh my god, the response token is 25. Damn it. Also, I have to put in the response text here. Response, response, text. What is response? Response is client dot models dot generate content. All right, gonna generate a response. All right, let's just save some tokens, or else I'm gonna again run out of them. So, I've written it again in the if condition. Let's write it again. One word. Shakira, Shakira. All right, we got the answer. That's what we wanted. That is verbose for you guys. Let's just continue with the whole thing again.
AI agents because it's usually pretty obvious when a calculator is broken, right? So it'll be really good for us to be able to make pretty. Okay, in chapter 2, we're actually going to start working with the project that our agent is going to work on, right? So we're building an agent, but our agent needs a code project to actually work on, right? And we're going to make it a calculator app. So it's going to be a really simple little app that can take math problems basically as input and do the math. So this will be a really simple project, and it'll be a really good one, I think, for our Gemini Flash AI agent because it's usually pretty obvious when a calculator is broken, right? So it'll be really good for us to be able to make pretty obvious bugs in the calculator so that our AI agent can then go fix it. Assignment: create a new directory called calculator in the root of your project. Easy enough. Calculator. Copy and paste the main.py and test.py files from below into the calculator directory. All right. So you might be like, Lane, why are we just copying and pasting code? We're not learning. We are. We're not copying and pasting the code for the agent. We're copying and pasting the code for the calculator app, which the calculator app is not the point of this project. The point of this
Let's copy paste both of them. I don't mind copy pasting, dude. You don't have to explain. Where is it? LLM chapters list. What will I learn? Functions. Where will I get the thing, bro? Start the course, of course. Chapter 2. No, I don't really have anything. So, yeah, assignment. Right. Make there. I have to. What do I need to? Okay, I need to make a file, right? Okay. And I'm just gonna copy this. Bhai, this is not actually a simple calculator. Oh, hi, this is actually a really tough calculator. What the hell? This is the final structure. I had to actually check this out, dude. Calculator slash main.py import sys from pkg dot calculator import calculator, and you do all of this. If you are importing the calculator, why just let's see if okay, this is this print calculator app uses this example, you print all of this, right? Expression, you make, what is this? I guess this is a bunch of tests. Unit tests, I guess. Yeah, unit test. All right, this is the testing phase. What is this? uh, and render.py. uh, what is this? Have this. I guess you run this, you guys. Yeah, I don't know, man. Let's just make a directory and just copy paste this thing. Yeah, all of them, all of them. First one is copy paste the main and test file. Event render.py. It's a pkg subdirectory. Oh, directory. Okay, this has another directory. This directory called pkg has another. So this has another what? Calculator.py. Calculator.py. I so render dot. All right, it makes sense. Now that we have made this, let's just populate render. What is render? This is render. Like, let's just go back and see the video.
Project is not to build a calculator, it's to build an agent that can work on a calculator. So I'm just giving you the code for the calculator. Again, it's the easiest way to do this is actually to go over to boot dev, go to these lessons and copy and paste this code. Again, totally free to have a boot dev account and to access all this content. So no worries there. All right, we've added those. Then get these out of my face. What's next? Create a new directory in the calculator app called PKG. PKG. This is important. We want our app that our agent works on to be a multi-directory app so that it actually has to use some of the file traversal tools that we're going to give it. Copy and paste this into calculator.py.
No boring classes. They build, they program, they launch. And in the process, they not only enjoy, but also become industry ready in 4 years. If you want your next 4 years to be filled with opportunities like this, then apply for NAP.
Oops.py. And then we've got, I think, one more render.py. Okay. All right, cd into the calculator directory and run the tests. So cd calculator uv run tests.py. All the tests pass, that's good. While still in the calculator directory, run the actual calculator app. So uv run main.tests.py. All the tests pass, that's good. While still in the calculator directory, run the actual calculator app. So uv run main.py. And it takes as input an equation. So we're going to give it 3 plus 5.
Test is not found. Test would be
5, and it renders out the answer. Cool. I believe the way I've structured this, it's been a second since I wrote this, is the calculator app's in its like current working state, and then when we're working on our agent, we're actually going to like break the calculator and then get the agent to fix it, that kind of stuff. So now we just run the tests from where do I run the tests from? From the root of the project. So back up here. There we go. All right. The tests from where do I run the tests from? From the root of the project. So back up here. There we go. All right, get files. We need to give our agent the ability to do stuff. We'll start with giving it the ability to list the contents of a directory and see the file's metadata, the name and size. Before we integrate this function with our LLM agent, let's just build the function itself. Now, remember, LLMs work with text. So our goal with this function is for it to accept a directory path and return a string representing the contents of that directory. Create a new directory called functions in the root of your project, not inside the calculator directory. Inside, create a new file called getfilesinfo.py. Getfilesinfo.py. And inside, write this function definition. Very good. Okay, here's how the project structure should look. Cool, we got that. The directory parameter should be treated as a relative path within the working directory. Okay, so getfilesinfo. Let's think about what this does for a second. This function definition info.py. And inside, write this function definition. Very good. Okay, here's how the project structure should look. Cool, we got that. The directory parameter should be treated as a relative path within the working directory. Okay, so get files info. Let's think about what this does for a second. It's going to take a working directory, and it's going to take a directory within the working directory. So imagine that our working directory is probably calculator, right? And then the directory might be the root, which would just be dot, which would represent, main.py, tests, and pkg. Or it could be something inside, like the pkg directory. Okay, if the directory argument is outside of the working directory, we should return a string error. This will give our LLM some guardrails. Okay, so this is actually a really important part. Without this restriction, the LLM might go running amok anywhere on the machine. So we're building in a very simple guardrail here where we're saying, if the LLM tries to use this function, because remember, we're like giving the LLM the ability to call this function. But if it tries to call it outside of the working directory, which is something that we're going to hard code, we're going to just disallow that, right? So the LLM will only be able to read files within the directory that we tell it can do so. So that's at least some kind of little guardrail on our system. Okay, so we need to actually start to call it outside of the LLM the ability to call this function. LLM tries to use this function, because remember, we're like giving the LLM the ability to call this function. But if it tries to call it outside of the working directory, which is something that we're going to hard code, we're going to just disallow that, right? So the LLM will only be able to read files within the directory that we tell it can do so. So that's at least some kind of little guardrail on our system. Okay, so we need to actually start implementing some of this. If directory is outside of the working directory, return a string with an error. So how do we do that? We need to, I believe the working directory is given to us relative to where the user ran the code. I'm sure there's some sort of standard library. Here's some standard library functions you'll find useful. Yeah, I'm sure I will find these useful. Okay, os.path.absolute, get an absolute path from relative path. Okay, so if we do absolute working dir equals os.path.abs path, pass in the working directory. We're going to need to import os, and then we're also going to want the absolute directory equals os.path.abs path directory. In fact, we need to handle the case where it's none. So if directory is none, directory, I can't spell, equals dot. So we'll just default to root of the working directory if we're not given a directory. That seems pretty straightforward. Okay, dot starts with. So now if the absolute directory, that should be if not absolute directory dot starts with the absolute working directory. So if it doesn't start with the absolute working directory, then the absolute directory must be outside, right? Otherwise, it would start with the same thing. So if it doesn't, we need to return with that error that we were told to return with, way up here, I think. Return an error string. And importantly, the reason we're returning a string here and not like raising an exception, which you might normally do in Python, is because the LLM is using this function. And we want the LLM to be able to read like the error that we give it. So it's easier just to work with strings. Otherwise, build and return a string representation of the contents of the directory using this sort of format. So let me just kind of copy this, and I'll plop this up here so I don't forget it. And then down here we can find, I think we're going to need some more of these standard library functions. Okay, join two paths together safely starts with, we got that one, os.path.isdir, check for paths directory. That all seems pretty straightforward. We want to list dir contents equals os.list dir, the absolute directory. Okay, and this is probably just a list. List of strings. Okay, that's easy. For file in contents. In fact, we should name this better. For file in files. They're not necessarily files. Let's call it contents. For content in contents, because like if we list the contents of the calculator app or the calculator directory, main.py and test.py are files, but pkg is a directory. So I don't want to call them files because that's going to confuse me. So what we can say is if, let's see, source file size is directory 2, right? So let's do is dir equals false. Actually, we just do isdir equals os.path.isdir and give it the, I think we need to join, right? We need to do os.path.join absolute directory to the content, right? Because I believe creates a new string object from the given objects. No, that's not it. From a list containing the names of the files. Yeah, so this is just like the names of the files. So I can't just use that in os.path.isdir because it needs a path to the file. So I have to actually join the directory we're working within to the content name. Okay, so now we know if it's a file or if it's a directory or not. The other thing we need to know is the file size. What do we do if it's a directory? I think that still works. So it's going to be something like file info equals os.path. Oh, it's just get size. I guess this would be just size. And then do the same thing. In fact, I'm going to...
I'll be back in 10 minutes. I'll go have my breakfast. Hello. Hello, guys. Yellow, guys. Yellow, guys. Hello, guys. Hello, guys. I'm back. I am back. I'm back. I'm back. I'm back. I am back. Bro, and first off, I'm not even trying to understand this thing, bro. I
String
have to.
and side, right? This function definition. Very good. Okay. Here's how the project structure should look. Cool, we got that. The directory parameter should be treated as a relative path within the.
Let's read what this guy says. And after this, what is the next chapter? Let's go to the next chapter. Validate path, right? Alright, let's see. We need to give our agent the ability to do stuff. Does that make sense? Huh? Alright, this makes sense. Let's see. We need to give our agents the ability to do stuff, alright? Let's just do some drawing for no reason. We need to do the ability to do stuff, right? So agent has the ability to do stuff. We will start by allowing it to list the contents of a directory and see each file's metadata and size. Alright. If this is our working directory and we have the calculator app inside it sitting. Mm, so what we are trying to do is is to allow a directory and see the metadata and see each file's metadata, right? Directory and metadata, name and size. All right, that makes sense. Size. That's what we want. Before we integrate this function to our LLM agent, uh, let's build the function itself. Now, remember LLMs work with text. So our end goal with this function is for it to accept the directory path. It has to accept the directory path and return a string that represents the contents of the directory If this is our directory, that let's say this calc, so what we are giving is the directory's path, right? Directory path, and return a string that represents the contents of that directory. We are expecting the directory's contents. The first step is is the most important, making sure that the request directory is safely inside the working directory that we allow the agents to use. So this, if this is a working directory, there, and this is the calc, this is the directory, that it has to be inside the directory itself, because we can't give AIs, agents to run around and use all our files, because can't let that happen. So that's dangerous. the but the first step is the most important, making sure that the request directly is safely inside the working directory that we allow the agent to use. Assignment: make a new directory called functions in the root of our project, not in the calculator directory. All right, it has to be in the root of our project. make it, make it, make it there. I didn't really do re that's a folder that I've made in the root. And what this guy is saying, make a new directory functions in the root of your project. Inside, create a file called get files info.py and start writing the following function there. All right, start doing it. Let's see. Um, get get underscore file underscore info dot py file underscore. That's so far. Let's just copy this, paste it. Working directory is a string. All right, the directory is also a string, which is expected to be stored. And we are expecting a string out of this function. All right, makes sense. And the key idea is the directory parameter. Let's see. Let's read this. The key idea is that the directory parameter will be treated as a relative path within the working directory. You have the working directory, and the key idea is the directory parameter. The parameter right here, the directory parameter. Let's just keep it there. Keep it. So the key idea is that the directory parameter, we have got parameters, right? We have got working directory and the directory parameter. Directory parameter will be treated as the relative path within the working directory. You have the working directory, and within that directory is a relative path. We'll allow the LLM agent to specify which directory it wants to scan, but the working directory will be set by us. Uh-huh. This means that we can limit the scope of directions and files that LLM is able to view. In relative to the working directory. So you don't really roam around. We don't really have that ability to roam around, right? So begin implementing the get files info function. First, we need to validate the path to the directory inside the working directory. What does that mean? We need to validate that the path to the directory is inside the working directory. Okay, it has to be, the directory has to be inside the working directory. All right, that makes sense. Use os.path.abs path to get the absolute path of the working directory. Absolute path of the working directory, for example, calculator. All right, let's just say for now, let's just say print dot. All right, I guess I need to import OS here too. Or postfix depending on what system you are on. This imports all the functions from postfix or NT. Unlike the stat, I have no idea. Let's just go with the flow. os.path.abs path. gonna take a while, but it's alright. This is the working directory. I wanna get the absolute path of this directory, and this can also be none, right? For that program not found. Okay, that program. Yeah. Okay, this is typo here. Get file info. Function is not defined. Function is okay. Yes, it has to be string. I have to put it right here, right? Here, right? This makes sense. Okay. ERAR Python slash CLI agent slash function slash function. What do you mean slash function? Okay. Do I have a okay? It's function. Now let's run this again. We'll see slash function slash functions. Why is this giving me slash functions slash function? Absolute path of the working directory is what I'm trying to get to, and let's just not give things that to says one missing argument. It's the working directory. How do I pass the working directory? That's how I do it. I guess so. This makes sense. Okay, this is the working directory. Dot is always the working directory, right? Get to the directory. Get start CW. Get file. So this is the current working directory. Then pass it to the function. I have to pass this to the function. Then what am I getting? What do you mean? This is the complete patch of the folder. All right, that makes sense. When I why can't I just use this? Why do I need to? is the relative directory. That's what I wanted to ask. Is dot. This means current directory. What the fuck? Oh, I just wasted my grandparent folder inside the current directory. SRC is folder inside the current directory. Okay. Let's say. No, 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 no. Let me do this. No, no, no. Get files info. Dot dot. I'm sorry. So sorry. I'm so sorry, sir. There we go. Dot dot. And I run this file. The hell, bro? Why am I doing this? Ah. Alright, now if I run this file, it's gonna show me the current working directory. Okay, this is the working directory. This is the source directory, I guess. That is the working directory. This. No, no, no. Okay. This is the working directory, and that is the grandparent directory. What I wanted was the source, right? The source is the folder inside the current directory. If I were to say, let's say src, what would that give me? Well, whatever. Let's go back. Let's get back and use to get to the absolute path of the working directory. Okay, I'll get to the absolute path of the working directory. For example, if you pass in calculator as a working directory, that might return you something like that. Okay, I need that. Oh, frick, bro, I should have gone through the whole. Hello. And one. Hello. I guess you can hear me right now. Alright. So what I'm going through right here, sir, is something called brain fog. I guess I'll end this live stream right now and I'll try to, at least complete this chapter 2. I got like 2 more chapters left, so I'll have to complete this chapter today. I'll do it. Chalo, bye guys.